Okay, grade 11s, here's the second part. So it is now exercise 7.12, and I'm doing questions G, I, K, and L. All right, this is part 2. Right, so let's have a look at question G. Question G is asking sine 2x equals cos 2x. All right. So there's two ways we could do this. I could change that one to a sine, or I could divide both sides by cos 2x and get a tan x is equal to 1. It's really much of a muchness. Which one should I do? Let me change this one to a sine. So how I'm going to do that is I'm going to say 90 minus 2x. So we get here sine 2x is equal to, as soon as I say this 90 minus, this becomes a sine. And we get 90 minus 2x. Okay, so that's our angle. That's our reference angle. So for the sine general solution, it'll be 2x is equal to 90 minus 2x plus K360, or we'll have this 2x is equal to 180 minus 90 minus 2x plus K360. Okay, let's solve for this one. I take the minus 2 to the other side, and we get 4x is equal to 90 plus K360. Divide through by the 4, and we get x is equal to 22.5 plus K360. All right, let's have a look at this one here. So we get 2x is equal to 180 minus 90 plus 2x plus K360. Take the 2x to the other side, it becomes a minus, and we get 0 is equal to 180 minus 90 is 90 plus K360. All right, so grade 11s, you can see here that 0 does not equal to this thing, okay? So for something like this, when it just doesn't make sense, this is no solution, okay? We can't have that. And then just write here, k is an element of the integers. Okay, but you could have very well gone sine x over cos x is equal to 1, so tan 2x is equal to 1, and then solve for that, and you would have got exactly the same thing. All right, moving on to question I. Question I is asking 2 sine squared x equals 3 cos x. Okay, so this is our problem here, the sine squared, and I'm going to use our square identity. I know that, and I'm just going to miss a step here, guys. I know that sine squared alpha is equal to 1 minus cos squared alpha. You guys have seen how I got that before, so just go back if you don't remember and then have a look. So I'm going to change the sine squared x to 1 minus cos squared x. 1 minus cos squared x is equal to 3 cos x. Distribute the 2 in, and then I'm going to bring this one to that side. So we get 2 minus 2 cos squared x minus 3 cos x is equal to 0. Then what I'm going to do is I'm just going to rearrange this from highest powers to lowest, and I'm also going to divide by negative over here. I want to make my highest power positive, so this becomes 2 cos squared x plus 3 cos x minus 2 equals 0. Okay, so what I'm going to do is I'm going to use my little substitution. You remember I make cos as x, so this becomes 2x squared plus 3x minus 2. Now that's a lot easier to factorize than having a look at a trig function, okay? If we had to factorize that, we would get 2x minus 1, x plus 2. All right. Now I'm going to back substitute. So this would give us 2 cos x minus 1, 2 cos x minus 1, and then cos x plus 2 equals 0. We have something times something equals 0, so that means that this cos x will be equal to a half, or cos x will be equal to minus 2. I'm going to look at this one first, guys. So if you go shift cos minus 2, you get a math error, all right? That just means that there is no solution for this one. So that was a nice, easy one. For this one over here, we go shift cos a half, and we get 60. So for this one here, x is equal to plus or minus 60 degrees plus k 360 for the cos general formula, okay, where k is an element of the integers. Nice and easy. Let's have a look at question K. Okay, question K is asking sine theta minus 20 equals cos theta. All right, what I'm going to do here is I'm going to change the cos to a sine by saying 90 minus theta. So we'll get here sine theta minus 20 is equal to sine 90 minus theta. Okay, that is our angle, that is our reference angle. So if the general solution for sine will be theta minus 20 is equal to 90 minus theta plus k 360, or theta minus 20 is equal to 180 minus 90 minus theta plus k 360. All right, let's sort out this one. I'm going to take the minus theta to that side and the minus 20 to that side, and we'll get 2 theta is equal to 110 plus k 360. Divide through by the 2, and we get theta is equal to 55 degrees plus k 180. All right, for this one here, I just need to distribute that negative in first. So we get theta minus 20 degrees is equal to 180 minus 90 plus theta plus k 360. Okay. Take the theta to that side, take the 20 to that side, and we will get, so theta minus theta is 0 equals 180 minus 90 is 90, plus 20 is 110, plus k 360. As you saw from the previous one, this does not make sense. You cannot have 0 is equal to whatever it is over here, so that is no solution. All right. And then k is an element of the integers. Okay, grade 11's last one. We're looking at L. Question L. We have cos 2x plus 10 equals sine 4x plus 20. All right, I'm going to change this one to a cos by saying 90 minus 4x plus 20. And we get cos 2x plus 10 is equal to cos 90 minus 4x plus 20. All right, what I want to do here, grade 11s, is I just want to sort out this one first, okay? Because I don't want to use something hectic like that in our general solution. So we'll get cos 2x plus 10 is equal to cos 90 minus 20 is 70 degrees, and then that minus with that will give us minus 4x. Okay, there's our angle. There's our reference angle, because they're both cos. So we've got 2x plus 10 degrees is equal to plus or minus 70 degrees minus 4x plus k360. What I need to do now, grade 11s, is I still need to solve for that x. And we have two parts of the solution. We have the positive and the negative. And that's what I'm going to do here. I'm going to break it down, work it out for the positive one, then work it out for the negative one. So let's look at the positive one first. So we have 2x plus 10 degrees is equal to plus, which is just going to give us 70 degrees minus 4x, plus k360. Take the 4x to that side, take the 10 to that side. So that'll give us 6x is equal to 60 plus k360. Divide through by the 6, and we get x is equal to 10 plus k60. Please remember to divide this by the 6 as well. All right, where k is an element of the integers. Now let's look at the negative one. So we have 2x plus 10 is equal to negative 70 minus 4x plus k360. If you're wondering where I'm getting this from, it's from here, where we had our general solution. So I'm looking at the plus part and then the minus part. Just distribute that negative in, and we get 2x plus 10 degrees is equal to minus 70 plus 4x plus k360. All right, going to take the 4x to that side and the 10 to that side, and we're going to get minus 2x is equal to minus 18 plus k360. Divide through by the minus 2, and we'll get x is equal to 40 plus k180, where k is an element of the integers. Now again, grade 11s, yes, I know I divided through by negative, and that's still a positive. It doesn't make a difference, because this k will take on integer values that will be positive and negative anyways, so it'll change when we do that substitution. All right, thanks grade 11s, and then I will do question 2 on Monday for you guys.